Hey guys, today we're going to talk about some more theorems with angles being inscribed in a circle. So we'll continue where we left off, and that was in the textbook. We're on page 725 now. And we're going to look at this theorem, theorem 10.8, about having an angle that is inscribed and intersects a diameter. So the theorem says an angle inscribed of a triangle intercepts a diameter or a semicircle if and only if that is a right angle. So this theorem is saying we have a circle and we have an angle that's inscribed. If this angle inscribed intersects a diameter, so a diameter would intersect about here. So if this inscribed angle is intersecting a diameter of the circle, then this angle is going to be a right angle. Or if this is a right angle here that's inscribed, then we know it's going to intersect the diameter, meaning the endpoints of the angle that fall in the circle are going to be the two endpoints of a diameter. And a way you can think about how this theorem is working is if you have this angle, and either if we knew it was a 90-degree angle, well, from the theorem we talked about in the past, the inscribed angle is half the measure of the arc that it's intersecting. So this arc would be 180 degrees because it would be double the 90, which would make it a semicircle, which would make this the diameter. Or if you knew that this was the diameter, you would know it's a semicircle, and this arc has a measure of 180. The inscribed angle is half of that, so it's 90. So that's really what this theorem is working with here. And we can do a couple of examples later. We'll talk about another theorem first though. So our next theorem of the day is on the next page, theorem 10.9, and this theorem says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. And here's the example they give us. They give us a circle like this. They give us circle A actually. And we're given this quadrilateral, something like this. It doesn't have to be any special type of quadrilateral. It can be just a general quadrilateral. And what this is saying is, since this quadrilateral is inscribed in the circle, what that means is its vertices fall on the circle like this. It's inside. Then we know like angle L and angle N are supplementary. Or angle K and angle M are also supplementary. And this works for a quadrilateral that's inscribed inside of a circle. And the way you can kind of think about this one is if you were to focus on angle L, that angle would be half of the measure of the arc KNM, right? Angle L would be half of the measure of KNM, or KNM. So we don't know exactly what its measurement is, but we know angle L equals 1/2 of, I said KNM, so this arc. And then if you think of angle N, that's the opposite angle, it's going to be 1/2 of KLM, of that arc. And if you think about those two arcs, in total, those two arcs make up the whole circle. So when you add these two arcs together, they're going to equal 360. But if you're taking half of their measurement together, so if you had KNM plus KLM, that should equal 360. The measures of those two arcs, because it makes the whole circle. But since you're taking half of them, you would be like distributing a half through it, so you'd be taking half of this. So it'd be equal to 180 then. So that's where the 1/2, or the two opposite angles, are going to equal 180. They're going to be supplementary to each other. That's where that's coming from. And we can use this when trying to find angles as well. Also, when you have an inscribed quadrilateral, you can really find a lot of different measurements of arcs. You can use, like angle M, you're going to find the measurement, it's going to be half of this arc here. So you can use the inscribed angle rules that we know to find measurements of arcs and angles when we have quadrilaterals. It's just really trying to notice when we have them. So we'll do an example of each theorem at work, and then you can go practice some on your own. So let's say we have a circle. That's a circle. And let's say we have, we'll do one with a little bit of algebra for the first one. So let's say we have, this right here. This will be our center. And we're going to have, this angle is 4x plus 2, and this angle is 9x minus 3. Since this angle here, the key thing is going to be recognizing when you can use this, because in isolation it's not too tough, because we just saw what the theorem was. But since this angle intersects the diameter here, or a semicircle, we know this angle is going to be a right angle, so then we can just make the equation, well, that 9x minus 3 plus 4x plus 2, we should know those two angles are going to be complementary, because at plus 90 equals 180, so these two should equal 90, and we should end up with 13x, and then when we bring everything over, it's going to be equal to 91. We're going to have negative 1 over here and add 1 to the other side, and then when you divide by your 13, you'll get x is 7 here. So if we're trying to find the value of x, x would be 7, and it's because that angle is intersecting the diameter. It makes a nice little right triangle for us, which could be really useful. An example of how we can use the other, we'll do one with less algebra and more just the concept. We'll do this example down here. And let's say we have this quadrilateral. It looks like this, and we'll have y, x, w, z, and we are given that this is 60 degrees, and we are given that this is 95 degrees. And let's say we want to find the measure of angle x. Well, the measure of angle x is going to be supplementary with the 60, so that means that x should equal 120. And the measure of angle y would be supplementary with the 95, so y should equal 85. And of course you can check and see if they add up to 360 for a quadrilateral, which they will. Once you know these angles, you also could find the measurements of different arcs, like angle x, that would tell us the measurement of the arc WZY, that would tell us the measurement of this arc, not the arc length, but the measurement of the arc. So we can use these angles of the quadrilateral to find various angles of different arcs in the circle as well. So I'll give you some problems to try on your own, and have a nice day.